So these are all words that you're going to want to kind of know what they are before you leave today. Okay, I think I see most people have got it. Okay, here's the definition of domain and range. And you have probably had those definitions before in school. But I just want to make sure that you've got those under control. Domain, when we discuss domain, we are talking about our x values. Okay? If you have a list of ordered pairs, and I ask you for the domain of that list of ordered pairs, your domain is going to be the x coordinate, the x value. When you look at a graph, you're going to look at the x-axis to determine what x values have been input into that graph. Another term for domain is called input, and in science you will hear it called the independent variable. Pretty much in this class we won't really talk about it as an independent variable, but unless you take statistics. Now if you take statistics, you will talk about independent variables. But in general, domain, x values, input, that's what we're talking about when we talk about domain. Range is your y values. Your output, in science it's called a dependent variable. The thing that you need to also know about range is that y and f of x are interchangeable. Okay? So I can either have a y equals a function or I can have f of x equals a function. Okay. Interval notation is one of those things that students struggle with at times. You have probably been exposed to it before, but typically you have to be reminded about how to use it. So I want you to look off to the side where the red number line is, and I have a closed dot. Students almost always remember that closed dot from middle school. So if you had a dot shaded in, that meant that that number on the number line was included in your solution. So if I tell you to pick a number that is greater than or equal to 5, can you pick 5 as one of those numbers? Yes. Yes, you can. 5 is included. So in algebra, instead of using the solid circle or the solid dot, we use a bracket. So that bracket means that the 5 is included. Okay? Now, if I told you to pick a number greater than 5, could you pick 5 as your number? No, you couldn't. Okay? That is why I have an open circle there. Could I have picked 5.01 as my number? I could. I could not pick 5. So in algebra, we signify that with a parenthesis. So down here where it says the bracket means the number is included, the parenthesis means the number is not included. Okay? Now, sometimes you're going to get a domain and or a range that is all real numbers. The way that we write all real numbers in interval notation is negative infinity to infinity. Okay? Okay. this is what we call a polynomial. It is a function. And if I wrote it as a function, I would write it f of x equals x squared plus 3x plus 2. Now, what is going on through the ceiling? So if my graph kept going and went through the ceiling, when would it stop? It wouldn't stop, okay? So that means anytime I've got arrows on things, that means that my graph is going and going and going and going and going, okay? Now, is there any reason that I couldn't plug in a negative 10 into x squared plus 3x plus 2? Could I plug your negative 10 in? Okay, tell me why. Okay, it's not on the parabola, but could it be if my graph just kept getting bigger and bigger and bigger? It could, because I could plug negative 10 in, so I would get 100 minus 30 plus 2. So what is that, 72? So my ordered pair for negative 10 would be negative 10, 72. Is that a point I could plot on this graph if I had an indefinite graphing sheet? Could I plot that point? I could. It would just be way, 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 way up there. Okay? So my parabola keeps going up and it keeps getting wider. It may keep getting wider in very small intervals because I'm squaring things, but it does keep getting wider. Okay? So I could put any number into this. I could put any number into this. So what I am looking at for my x values are any of these right here. I can put in any of those values. I could put negative 1,000 in and get a corresponding y value. I could put positive 1,500 in and get a corresponding y value. So my domain for this is all real numbers. Okay, all real numbers, and I write that negative infinity to infinity. So negative infinity is down here, and positive infinity is here. So when I have an answer that's all real numbers, that means I can plug anything in. Okay? So this is a polynomial, and one of the definitions of a polynomial is that your domain is all real numbers. Now, what you need to look for in this class, there are two situations where you have to limit your domain. There's two situations where you have to limit your domain. Okay, in this class, for the purposes of this class, the two situations where you have to limit your domain is when you have a variable in the denominator. Okay? When you have a variable in the denominator, you have to limit your domain. Or if you've got a variable in a square root. Okay? Those are the two times that you are going to have to limit your domain in this class. Now, you are allowed to use a calculator in this class. If you don't have one with you yet, go ahead and pull your phone calculator out. Okay? Now, on that calculator, I want you to do 3 divided by 0. 3 divided by 0. What happens when you do 3 divided by 0? Error. Okay? You get something that is undefined. Now I want you to do 3 divided by negative 1. 3 divided by negative 1. Okay, negative 3. So is it okay to divide by a negative number? Okay? Divide 3 divided by 2. 3 divided by 2. 1.5, 1.5. So can I divide by a positive number? Yes. Okay? So it is okay to have negative numbers and positive numbers in the denominator. Okay? What can I not have? I can't have 0. I can't have 0. So I cannot have 0 in the denominator. That is undefined. It is error. Okay? So I cannot have 0 in the denominator. So in this situation, it does not matter what's on top. My numerator does not matter at all. The only thing that matters is my denominator. So what I do to find the domain of this is I set denominator to 0. Okay, I set my denominator to 0. So I have 3 minus x, and I'm going to say cannot be 0. So 3 minus x, that's what's in the denominator. It does not matter what's in the numerator. The only thing that matters is what's in the denominator. So I set my denominator equal to 0, and I solve. So I'm going to say negative 3 from both sides. Then I have negative x cannot be negative 3. I divide both sides by negative 1. And what is it that x cannot be? If x is 0, I get 3 in the denominator. So that's okay. When I solved it, what did I get? X cannot be 3. X cannot be 3. Now, I want us to look at this graph. Look right here. Does anybody know what that's called? Okay, it is x equals 3. Does anybody know what it's called, though? It's an asymptote. It's an asymptote. And my graph never crosses that asymptote. Never, ever, ever, ever. Okay? From the left, it goes up to positive infinity. From the right, it goes to negative infinity. Okay? So it never crosses that asymptote. So I can put any number I want to into this function except for 3. Because when I put 3 in, I get 0 in the denominator and it's undefined. Now, I want to know how do I write it in interval notation? Okay? Now, 3 is not included. 3 is not included. So I'm going to start on the left-hand side. What is at the other end of that arrow on the left-hand side? What kind of infinity? Negative infinity. Okay? So I have negative infinity, and then I go all the way, but I do not include what number? 3. Okay, so I go all the way to 3. And what do I put by that 3 to show that it is not included? Parentheses. Excellent, a parenthesis. Okay? This is what we call a union sign, and it means or. Okay? That just means or.
Could we put or do we have to put that?
For it to be in interval notation, you have to put union. Yeah, if you're just talking, you can say or. Okay? Then I don't include 3, but how far do I go after 3? Infinity, positive infinity. Okay. So my answer to this is this right here. This is my answer. That's what I'm looking for. I am looking for my domain in interval notation. Okay? So we have to look for a variable in the denominator. That is one of the two things that we're looking for. A variable in the denominator. Okay, a variable in the denominator. Okay, the second thing that we are looking for is a variable inside a square root sign. That's the other thing that we're looking for. So I can write this as f of x equals the square root of x minus 16. Now, I want you to take your phone or your calculator, and I want you to take the square root of 0. Now, if you've got a smartphone, sometimes you have to turn that horizontal to get your square root done. Okay? Yes. So if I put 0 inside a square root symbol, my answer is 0. Okay? So is that allowed? Is 0 allowed inside a square root? Sure. Yeah. Is 0 a real number? Yeah. 0 is not a problem. Now put -1 in there and take the square root of -1. Square root of -1 is not 1. Square root of 1 is 1. Error. Okay? You cannot have a negative number. Now, in a couple weeks, we're going to talk about imaginary numbers, but imaginary numbers are outside the set of real numbers. Okay? So it's important that you realize imaginary numbers are outside the set of real numbers. Okay? So here, 0 is okay. Negative numbers are not okay. Okay? 0 is okay, but negative numbers are not okay. So the way I solve this one is I take what's inside the radical and I set it greater than or equal to 0. It is okay if I get 0. Now, what happens here is students usually remember that their rational can't have a 0, that your fraction can't be over 0. Students almost always remember that. But then they don't remember this, and so then they just set it equal to 0 and say, okay, well, x can't be, or x minus 16 can't be 0. So there's two different rules for that. And think about when that situation is undefined. So for this situation, I've got x minus 16 is greater than or equal to 0. So I add 16 to both sides. And I get x is greater than or equal to 16. So if I plug 16 into this function, and I say 16 minus 16 is 0, the square root of 0 is 0. And that is completely okay. If I were to plug something less than that, like if I plugged 15 in, 15 minus 16 is -1. And that's not allowed. So the range of this function is all numbers 16 or greater. Do you see how I have the bracket for that one? I have the bracket for that one because 16 is included. And if you look at the graph, you're going to have a dot there, a solid dot, because 16 is allowed. 16 is okay. Okay? 16 is okay. Okay. Can I go to the next screen? Good? Okay. Okay. This is what we call a piecewise function. This is a piecewise function, and I want you to pretend that we've got arrows on those two dots. Okay? So we're going on forever in that direction. The the part where it says f of t equals t plus 1, 1, and negative t plus 3, that is it's just what's happening in this particular piecewise function. Okay? You don't need to worry about what that says. You don't need to worry about that at all. What I want us to focus on is the graph itself. I want us to look at the graph itself. So the first thing that I want us to look at is the domain of this function. The domain of this function. Now remember, the arrows mean it keeps going forever. It keeps going forever. So when I look at this as my domain keeps going forever. So what is the domain of this particular function? What's the domain of this?
Negative infinity to positive.
Good. It's all reals. Negative infinity to positive infinity. Okay. Now, we haven't talked about range much. So now I want us to look at range. Range is my y values. Range is my y values. Is there anything up here that my graph is dealing with? No. What is my highest y value? 1. The highest y value I deal with is 1. Okay? And is that 1 included? It is. Okay. Now, a lot of students will look at this graph right here and they will say, okay, 1 is included, and then I'm going down, and what's at the end of this down arrow? What infinity is down here? Okay, a lot of students will write this right here. A lot will write that, okay? But that is wrong. You always write your interval notation with the smallest number first. Okay? So what's my smallest number with my range? Negative infinity. And then I go up to positive 1. Okay? So my range is negative infinity to 1. Okay. Now we're going to talk about increasing intervals, decreasing intervals, and constant intervals. Okay? Okay. Now, I want us to look at what is happening right here. And you can think about what kind of slope is represented by that red line. And I'm starting at negative infinity, and I'm moving this direction. So when I move from left to right, just like we read, what direction is that line going? It's going up. It has a positive slope. Okay? My y values are increasing. Okay? So one way to look at that is thinking about it being a positive slope. Now, when I am talking about increasing, decreasing, and constant, we are always talking about my x values. So this is the corresponding x values. So I want to know the interval associated with when this graph is increasing. Okay? Where does that highlighted red line start? Okay, we're going to start from the left. So think about reading from left to right. So where is far left?
Infinity.
negative infinity. Okay? So we're starting at negative infinity. Now you are only focusing on the x values. So where does that stop? Where do my x values stop for the increasing? At 0. Good. Okay? A lot of students want to put 1 right there because of the y value. Okay? It is not the y value. You are only looking at the x value. The only time that you use the y value is during range. That's the only time that you use the y value. Okay? Now I want us to look at this part of my graph. Actually, I don't. I want to look at this part of the graph. Okay, what is happening there? What's happening there? What kind of slope does that line have? It has a negative slope. Okay? So that is where I am decreasing. So I want you to think about where is the x value that I start decreasing. I'm not looking at the y value. I'm looking at the x value. Where do I start decreasing on the x? What number is there? 2. 2. And then how far am I increasing? 2 to what? Infinity. Good. Now, the last one that I'm going to look at is this right here. What is happening right there? It's staying the same. It's got a 0 slope. There is no change. There is no change. So when we are looking at something that's constant, there is no change. And here is where we're looking at it as a constant. And what are my x values there? So we're only looking at my x values. How far do I go? To 2. I go to 2. Okay. So what we're looking at is we are looking at the intervals when my graph is increasing and decreasing. Now, I can tell you, a little real life scenario on what this might look like, but no laughing and no judging. Okay? So, the red part of the graph is Alicia from Thanksgiving to Christmas. What do we do from Thanksgiving to Christmas? We eat all the time, and we go to parties. Okay? So the red line can represent me gaining weight between Thanksgiving and Christmas. Okay? Then at Christmas, I think, okay, I don't want to gain any more weight. But there's no way I'm going to make it through this next week if I start a diet the day after Christmas. So, for New Year's, maybe I eat some of the cake, just not all the cake. Okay? And so, in between Christmas and New Year's, what has happened to my weight? It's constant. It stayed the same. I didn't gain any more weight because I kind of got out of holiday mode, but I didn't lose any weight. I broke even, and that might be the only goal you can have in between Thanksgiving or in between Christmas and New Year's. Then on New Year's, what happened? What did I start? A diet. I started keto or whatever. Okay? And then you lose weight. So that's kind of a way to think about this. My interval for my positive slope or my increasing was Thanksgiving to Christmas. My interval for my constant was Christmas to New Year's. My interval for the green is after New Year's. And I really should say for the red, it would have been before Christmas. Anything before Christmas. I was gaining. Okay? And that's just a made-up story. I promise. Okay? So So now we're going to look at another type of graph. It's not going to be a piecewise. Can I move off of this? Move off of this. Okay. Now we are going to talk about relative minimums and maximums. Okay? So for a relative minimum or a maximum, you are going to change direction. Change direction. Now, for this particular graph, we keep going on up and we keep going on down. Okay? So, my relative minimum and my maximum, this is my relative maximum because it's my highest point. That's not the infinity or the negative infinity. And this is my relative minimum. It is where we change direction. Now, I want you to pull out your phone because I'm hoping that you have downloaded Desmos. So I want you to pull out your phone and go ahead and graph this, x to the third minus 3x. This is a great opportunity for you to start learning how to use Desmos. Then I want you to touch the part that appears to be the relative maximum. Touch that part. And it will give you the relative maximum and the minimum. You just have to touch the point. The important thing about the relative maximum and the relative minimum is you are changing direction. Okay? You are changing direction. That's what's happening. Now, I'm going to give you about 3 minutes, and I want you to identify the domain of this, the range of this, where my graph is increasing, where this graph is decreasing, and where this graph is constant. Now, you are focused on your x values. So you are going to use these numbers. That's what you're focused on, your x values. What's the one exception? What's the one exception when you're not focused on the x values? Range. Range is your y values. Okay, I'm going to give you 3 minutes. Okay, here we go. So our domain, because of these arrows, I want you to look at where your domain is. Okay? Your domain includes everything because those arrows keep going and going and going. You can plug anything into x to the third minus 3x. You can plug anything in there. So your domain for this is negative infinity to infinity. Now, as far as the range is concerned, oftentimes students will want this to be the range. They'll only want in between 2 and negative 2. Okay, and 2 and negative 2. But that is not true because of those arrows. On the right, my arrow keeps going and going to what? Positive infinity. On the left, where does it go? Negative infinity. Okay? So my range here is also negative infinity to infinity. Okay. Now, increasing. I am increasing here and I am increasing here. Okay? That's when I'm increasing. Okay? Now, my increasing starts at negative infinity and it goes to this x value right there. It's negative 1. So I've got negative infinity to negative 1. And I also have 1 to positive infinity. Okay, because I've got 2 different places that this graph is increasing. Now, for decreasing, I have 1 interval that's decreasing. And it is right here. Okay? And for my number line, that is only from negative 1 to 1. So my decreasing variable or interval is negative 1 to positive 1. Okay? So you are looking at the x-axis or the x values. So for domain, you look at x value. For increasing, decreasing, and constant, you're looking at the x value. Y value is range only. Okay? Where is my graph constant? Where is my graph constant? It doesn't have anything for graph that is constant. Your homework is going to want you to put does not exist. That's D-N-E. D-N-E. And it tells you that. On every single problem it says, if does not exist, put D-N-E. Okay? So for constant, we do not exist. Okay. Can I move on to the next slide? Pictures? I see a couple people taking pictures. Okay. Now, I am going to switch gears up to what's on the board. And this is one of those situations where not everything gets recorded on video. Okay, so I want you to look at these pictures on the board. We talked about determining if something was symmetric to the x-axis. We talked about that on Thursday, and you practiced that in your homework last week, determining if something was symmetric to the x-axis. What you did to determine that is you took y out and you put negative y in. Okay, that's what we did. Then we also had to determine if something was symmetric to the y-axis. And the way that we determined that is we took x out and we put negative x in. Okay? Then we looked at symmetric to the origin. Symmetric to the origin. And the way we tested algebraically, if something was symmetric to the origin, we replaced x with negative x and y with negative y. Okay, so we did both of those. Now, we are just going to give that a new name. we're going to do exactly the same thing, but instead of testing for symmetry across the x-axis, y-axis, or origin, we are going to determine if it is an even function or an odd function. Now, do you remember the vertical line test? Remember the vertical line test? Does this graph pass the vertical line test? No, this is not a function. So the reason that symmetric to the x-axis doesn't have a special name is because this is not symmetric, or this is not a function. Okay? So when we are dealing with functions, we will never deal with something that's symmetric to the x-axis, because anything that's symmetric to the x-axis isn't a function. So now we are only talking about even functions and odd functions. Okay? We're only talking about even functions and odd functions. Now, if I make this statement, all seniors at Montevallo are students. If I say all seniors at University of Montevallo are students, is that a true statement? All seniors.
Seniors in the sense of grade or seniors in the sense of age?
Not age. Seniors as rank at the college.
Yes.
Yes, it's a true statement. All class-ranked seniors at the University of Montevallo are students. Okay? If I reversed that and I said all students at the University of Montevallo are seniors, is that a true statement? No. Okay? So just because it works one way doesn't mean the reverse is true. And that's what you need to understand about even and odd functions. Okay? You can have an even function, you can have an odd function, or you can have neither. You can have neither an odd nor even. So, right now I'm talking about odd functions. Odd functions. All odd functions have an odd exponent. All of them do. Okay? For the purposes of this class, all of them have that. Okay? Now, but the opposite of that is not true. We cannot say all functions with an odd exponent are odd functions. You have plenty of functions that are raised to the third power that are not odd functions. Okay? Now, the reason that this is helpful is because if you have an odd exponent, you only need to test to see if it's an odd function. If it has an odd exponent, we already know it's not an even function. Okay? So if it's got an odd exponent, you only test to see if it's an odd function. The same is true for even functions. All even functions have an even exponent. All even functions have an even exponent for the purposes of this class. Okay? But if you have an even exponent, that doesn't always mean it's an even function. There's tons of functions that have an even exponent that are not even functions. Okay? But if you have an even exponent, you only have to test to see if it's an even function. If it's got an even exponent, we know it's not an odd function. We know that. So we only have to test to see if it's even. Okay? So that is a reasonable thing to take a picture of, especially because it's not on your videos. You just kind of hear me talking. Okay? And just FYI, next Tuesday is another day where we do almost everything on the chalkboard. We're going to be working with Desmos, and so I can't record inside of Desmos. So definitely, you need to be in class every day, but next Tuesday there's not going to be videos to supplement. Okay, so the way that we determine if a function is even is we replace x with negative x, just like we did to see if it was symmetrical to the y-axis. And the way that we determine if something is an odd function, we replace x with negative x and y with negative y. And that's testing to see if it's symmetric to the origin. So let's do some of these. Okay? Now, these include the graph, and that's for a visual. You always have to determine it algebraically. You always have to determine it algebraically. Okay? This has an odd exponent, so I am only checking to see if it's an odd function. What's the equivalent to f of x? What can I write instead of f of x? Good. So I have y equals x to the third minus x. In order to determine if something is an odd function, I replace y with negative y and x with negative x. Okay? Negative x, or negative 1 x to the third power, leaves me with negative x to the third, because negative 1 raised to the third power is negative. Negative 1 raised to the third power is negative. Then I have minus a negative, so that becomes plus. Now I'm going to divide everything by negative 1. I get y equals positive x to the third minus x. Is that what I started with? Yes. So what kind of function is this? An odd function. Okay, so yes, this is an odd function. And when you look at the graph, if I fold it in half at the y-axis and fold it in half at the x-axis, it's going to be on top of each other. So it is symmetric to the origin. Okay? Can I do the next one? Okay. Here we go. This is f of x. F of x equals x squared plus 1. Okay? That's the same thing as y equals x squared plus 1. When you look at the graph visually, you can see that if you fold it over, it's going to be symmetric. Okay? But we have to show it algebraically. We are only testing for even because I have an even highest exponent. So I'm only testing for the even. Okay, and in order to do that, I replace x with negative x. Okay, so x with negative x, and that's negative 1x. Negative 1 is being squared, as well as the x. What is negative 1 squared? Positive 1. Okay? So I'm left with 1x squared, or just 1x. Is that the same thing I started with? Yes. So this is an even function. This is an even function. Okay? Now, the last one that I want you to look at, it's not symmetrical to anything. Okay? If I folded it over the y, it's not symmetrical. If I folded over the x, it's not symmetrical. If I folded over the x and the y, it's not symmetrical. So this is an example of an exponent to the third power. So I have an odd exponent. This is not an odd function. Okay? So odd exponent, not an odd function. Okay? Odd exponent, not an odd function. Now, the reason I know that, and if I can show it algebraically, okay, so I've got to replace y with negative y, and I replace x with negative x. Okay? Negative x to the third, it stays negative. When I divide this all by negative 1, I end up with y equals x to the third plus 1. Is that the same thing I started with? No. So this is not an odd function. So this is neither. Do I need to test for even? Do I need to test for even? No, I do not need to test for even because it doesn't have an even exponent. Okay? Okay. Now, the last two things that we're going to do, you already know how to do. I just need to remind you how to do it. Okay? That's all. You know how to do it. I just want to go through a couple to remind you how to do it. You've been exposed to this plenty of times before. I want you to find the roots of this function, the solution of this function, the zero of this function. Okay? When I say roots, solution, and zero, I am talking about the same thing. And what am I talking about? My x-intercept. This is what I'm talking about right here. X-intercept. The other way is where graph crosses x-axis. And I've included the graphs here, but you're going to show it algebraically. You're going to show it algebraically. So the way that you do this is f of x equals 3x minus 15. You set f of x equal to 0. Okay? That's how you do it. Okay? Set it equal to 0. And this is what you're trying to find. Where does it cross the x-axis? Okay? Now, if it looks like this, okay, f of x equals 3x squared plus x minus 10. We're going to set it equal to 0, and then what do you have to do? The opposite of that, but you're right. Factor. Good. You've got to factor. Okay? If you don't know how to factor, we need to talk at quiz 0. We definitely need to talk at quiz 0. So you're going to factor and solve. Now, 13 and 14 you might have forgot how to do. So I'm going to remind you. Okay? We are still going to set this equal to 0. So it's the square root of 10 minus x squared. We set it equal to 0. What do I do to get rid of the square root? You did it in Math 131. You're close. You square. Yeah, you square both sides. So I am going to square my 0, and I'm going to square this. So I end up with 0 equals 10 minus x squared. Okay? Okay. Now, the next one, it's f of x equals 2x minus 3 over x plus 5. So I've got 0 equals 2x minus 3 over x plus 5. I am going to multiply both sides by that denominator. what is x plus 5 times 0? 0. Okay? And here, my x plus 5's cancel because I've multiplied both sides by that. So now I'm solving a simple equation, 2x minus 3. Okay. Now, for the last one that we're going to do today, you know how to do it. It's just worded weird. Okay, are you ready for it? So the directions for this one say, find what values of x where f of x equals g of x. So you're given an f of x and you're given a g of x, and we want to know when are those two functions equal. You are setting the functions equal to each other. This is what you're looking for. You're looking for where the functions cross. You're actually solving a systems of equations. Okay? You're looking for where they cross. You're looking for where they cross. Now, the way to do that is you say f of x is x squared minus x plus 6 is equal to negative 4x plus 60. So you set them equal to each other and solve. Now, because this is a quadratic, and that means it's raised to the second power, it means it's not linear. In order to solve it, what do I have to get it equal to before I can factor? 0. Excellent. So I've got to move my negative 4x to the other side. So do I do that by adding 4x to both sides? What do I subtract from both sides? Excellent. Okay? So I end up with x squared plus 3x minus 54. Now, can I factor that? And I can factor it, okay? I need two numbers multiplied together give me negative 54, and added together give me 3. 9 and negative 6. Okay, I solve. So x is 6, and x is negative 9. Okay, so my answer is 6 and negative 9. 6 and negative 9 is my answer. Okay? Now, at my graph, here is my x value when it crosses. Was it 6 or negative 6? It was 6, right? Okay, so that's my x value when it crosses. Guess what x value this is when it crosses? Negative 9. Okay, so I'm looking for the x values of where they cross. The x values for where they cross. Okay, you know how to do that. It's just that getting them set equal to 0, students get stumped with. Okay? Quiz on Thursday.